Okay, so today we're going to learn about how to make a lab report. Woo! This will get you ready for tomorrow when you get to start to make one. So there's a bunch of different sections. We're just going to go through each one by one. The first thing on a lab report is going to be a purpose. Now, we're not going to do an abstract because, we don't need it at this level yet, but we'll talk about this more once we see each other, maybe. But anyways, the first thing that's going to be on your lab report is a purpose. Okay, what is a purpose? A purpose says what you did. Okay, like what you did, what you found, what you accomplished, what you're seeking to do. Like, for example, your lab report from this week will say your purpose was to calculate gravity through motion, right? Through free fall motion. Whatever, paraphrase that. It's anything like that. And you should also say if you were successful. Okay? So you could say this experiment was to calculate gravity through a ball falling, and we were successful in doing that. Or we were not successful in doing that, we had too much air. Whatever you want. You're allowed to say you weren't sure, you can't tell if you were successful due to error. That is an acceptable thing here. You're in high school. It's okay. It's good to recognize that. You're not going to lose points for not having accurate data at this level. You're going to take classes in college that'll teach you how to take more accurate measurements and all that jazz. And we can't do that online anyways, so that is a-okay. But this is what you're going to have in your purpose. It's going to be, like 2 or 3 sentences maybe. It's going to be brief, and that's okay. Remember, content matters more than context. Alright, materials. You're going to list off the materials that you did. You can use bullets or numbers or whatever you want. So you could say you used a ruler. You used a stopwatch. You used a tennis ball. Whatever. Now, in some higher up situations, for like your stopwatch, you might want to say which model it was. Model. But we're not worried about that quite yet. But just so you know, if you use fancy equipment, that's the kind of thing that you're going to need, because it's for tracking, because maybe there's an error or whatever in that software, and that's how they would tell. Okay, so that's materials. That's going to be another easy section. Next one is going to be procedure. Procedure is going to be a list of things that you did. So I dropped the ball. Well, you'd probably say a little bit more than that. Drop the ball. And then I recorded. Then I measured the time. And then I calculate acceleration. Whatever. But the main thing for procedure is you're going to write down what you actually did. Okay? So you're not going to write down what you tried to do. You're going to write down what you actually did. What do I mean by that? I mean, what you're going to do is we measured the height of the table to be 2.4 meters. We rolled the ball off the edge of the table while we were recording it. The ball hit the ground. We looked at the video. We measured that the air time of the ball was 3.5 seconds. Whatever it was. Okay? So don't write. You're not going to copy verbatim what I wrote in my procedure, because mine is instructions for you. Yours is a list of things that you actually did. All right? So that's the main difference. Okay? So let's look at the next section. The next section is data. So this is just going to be the numbers you got. Alright, this will usually be a chart, And in fact, it is a chart. So you'll have a trial, you'll have a distance, you'll have a time, and you'll have an acceleration, and that's going to be your data. Now, technically your acceleration is from your calculations, but we don't always separate the data and the calculations as much. It kind of depends on the experiment. Since there's only one calculated value for here, it's easier to just tie it in with the trial. Okay? So when you have your data, make sure you have the units in there. They're usually in parentheses, minutes, or meters and seconds. You're allowed to have like non-standard units there if that's what you measured, and then you'd have, you know, converted in another column or in the next section depending on whatever it was. Okay, so let's look at the next one. Calculations. Calculation is sometimes separate, sometimes together with data. When is it going to be which one? Well, it's your lab report. Do it in the way that makes sense, okay? But what your calculations is going to be focusing on is your calculated numbers. Surprise, surprise. So these are numbers that you didn't measure directly, but you calculated from your measurements. In this case, it's your acceleration. Okay? Now, we're going to include our acceleration within our data because it's the only calculated number you're going to have here. But the other important thing to have, this will often be a table, you know, if it makes sense. And the other thing you're going to have is sample calculations. Okay? What we mean by this is you're going to have to show how you got those calculated numbers. You don't have to show it for every single trial, but you have to show it for at least one trial, and then it's expected that it's all done the same. Okay? So for one trial. Okay? Now, what you can do is you can type it in using the math. If you push Alt, oh, sorry, we're not using Word. You can use the equation editor in Word and then copy paste it if you want, or in Google. I don't know how to use it in Google because I always use Word. Alternatively, you are allowed to, at this level, to write it out on a piece of paper neatly, take a picture of it, and then paste the picture into your document too. That is a-okay for this level. So you're going to need a sample calculation, one of each calculation you did. So you're going to have to show how you calculated the acceleration for just one trial. You only need to do it for one trial. Doesn't matter which trial either. Okay, let's look at the next one. The last one is the conclusion. So the conclusion is going to be focused on two main things. Alright? The first thing you should reiterate, or I'm sorry, three main things. The first thing you should reiterate, did you accomplish the goal? Or the purpose, right? That's good to do. Yes, we accomplished the purpose because the experiment worked well. Whatever. The second thing you're going to do is you're going to look for errors. So, sources of error, right? What were some error sources in your experiment? So you could say, well, we had a problem because there was a lot of friction between the ball and the table. Whatever, you know. Come up with some source of error. I wouldn't write the one I said because that's not actually true. The other thing you have to be careful for when you're doing a source of error, please do not ever say human error. Well, that's one of my favorites. Because what is human error? Well, if, you know, human error, what do you mean? I don't know. It means you can't think of it. You have to think of specific cases because this is critical thinking kind of stuff. So, human error, you didn't measure carefully enough. Well, why didn't you just measure again? You didn't record well enough. So why didn't you just record again? So don't ever say human error, please. And the other thing you should never, ever say is calculation error. This one's a little more rare, but it's even worse because if you made a mistake in your calculations, why didn't you fix it instead of talking about it? But whatever. So your sources of error, please don't say these. You can find other things. Number 3, besides your sources of error, you want to think about how you can fix them or reduce them. I know some of them you'll never be able to reduce to 0, but how can you reduce error? All right. If you want to make yourself look even better, you should mention how the error affects the data. So for example, if there was friction between the ball and the air resistance, right? That's a popular one. Air resistance, would that drive your values upwards or downwards? So is the acceleration you got going to be higher or lower because of air resistance? That's one way to think of it. And then you could think about how you can reduce error. So maybe you wanted to do this experiment on the moon because there's no air on the moon, so there won't be air resistance, or some other way to reduce air resistance. So you're just trying to come up with a solution to reduce the error. Yeah. So those are your sections of your lab report. So we're going to type those onto a document that you'll see set up for you tomorrow.